In 2023, the James Webb Space Telescope pointed at a planet 124 light-years away and found three molecules in its atmosphere that should not exist together on a dead world: water vapor, methane, carbon dioxide, and one molecule that should have been there was completely missing. That combination stopped researchers at the University of Cambridge mid-analysis because in every model they had ever built, those chemicals in that exact pattern pointed to only one kind of world: a planet hiding a liquid water ocean. The planet is called K2-18b. It is 2.6 times the size of Earth and 8.6 times heavier. It orbits a dim red dwarf star in the constellation Leo, completing one trip every 33 Earth days, and it sits inside the narrow band where temperatures allow liquid water to exist. Not too close to boil, not too far to freeze, the exact right distance. For years after its discovery by the Kepler telescope in 2015, K2-18b was just another data point, one of thousands, too far to visit, too quiet to make headlines. Then the Hubble Space Telescope found water vapor in its atmosphere in 2019. And when JWST followed up with the most powerful instruments ever pointed at an exoplanet, three reasons emerged that turned this quiet world into the most closely watched planet outside our solar system. Here is how scientists read the atmosphere of a world they will never touch. When K2-18b passes in front of its star, a sliver of starlight filters through the planet's atmosphere. Different molecules absorb different wavelengths of that light, leaving chemical fingerprints the telescope reads like a barcode. The light that reached JWST left that star system 124 years ago, before the Wright brothers flew. And when it finally arrived at the telescope's sensors, it carried the chemical secrets of another world embedded inside it. Those secrets are the first reason scientists believe K2-18b is hiding an ocean. JWST confirmed water vapor, methane, and carbon dioxide in K2-18b's atmosphere. Finding water vapor alone would mean very little. Many planets have traces of water in gaseous form, but this specific combination, water plus methane plus carbon dioxide with ammonia completely absent, matches only one type of world in every atmospheric model scientists have built: a planet with a liquid water ocean beneath a thick hydrogen-rich atmosphere. On a lifeless gas ball, ammonia should be abundant. Its absence suggests something is actively removing it from the atmosphere. One of the most effective processes that does this is dissolution into liquid water. Ammonia dissolves readily in oceans. If K2-18b has a vast body of liquid water interacting with its atmosphere over millions of years, the ammonia would be pulled out of the air and absorbed into the sea, which is exactly what the chemical signature shows. Researchers estimate water could account for a significant fraction of this planet's total mass. Some models place it near 50%. To put that in perspective, water makes up just 0.02% of Earth's mass. If those models are correct, K2-18b does not just have an ocean, it is an ocean. A world where water is not a feature on the surface but a fundamental part of what the planet is made of. Scientists did not photograph an ocean. They found something more subtle: the chemical aftermath, the invisible fingerprint left behind when liquid water exists long enough to reshape an entire atmosphere. Every molecule JWST detected tells the same story, and every molecule that was missing tells it louder. The second reason goes beyond chemistry. It is about what kind of world K2-18b actually is, and why that answer could multiply the number of habitable planets in the galaxy by millions. In 2021, astronomers at the University of Cambridge proposed a brand new class of habitable planet. They called them Hycean worlds. Planets with vast liquid water oceans topped with thick hydrogen-rich atmospheres. These worlds would look nothing like Earth: bigger, heavier, wrapped in hydrogen rather than nitrogen and oxygen, more like small Neptunes than rocky terrestrials, but they could still be habitable. K2-18b did not just fit the Hycean profile, it became the prototype that defined the entire category. Every parameter checked: the right size, the right mass, the right orbital distance. The estimated surface temperature sits around 73 degrees Fahrenheit, warm enough for liquid water, comfortable enough for biology. Here is why this matters beyond one planet. Scientists spent decades searching for Earth twins, rocky planets the same size and temperature as ours. Those planets are extraordinarily rare, but Hycean worlds could be everywhere. If K2-18b proves that ocean planets can exist in a completely different size class with a completely different atmosphere, the number of potentially habitable worlds in the Milky Way does not increase by a small percentage. It multiplies by orders of magnitude. Madhusudan argues K2-18b is a Hycean ocean world, a rocky planet with a liquid water ocean covered by hydrogen atmosphere, potentially harboring microbial life. Skeptics like Nicholas Wogan argue it is a gas-rich mini-Neptune with no solid surface and no ocean, where methane is produced through geological and chemical processes alone. Both models are published in peer-reviewed journals. Both cite the same JWST data. Both reach opposite conclusions, and both researchers know that the next round of telescope time will prove one of them wrong. The most studied exoplanet in the galaxy is either an ocean world that could host life or a giant gas ball with no surface at all. The same data, two answers, one telescope that can settle it. But before that answer arrives, there is one detail about K2-18b's potential ocean that makes it unlike anything that has ever existed on Earth. If K2-18b has an ocean, it would not look like any body of water a human has ever seen. Earth's oceans sit beneath a thin atmosphere roughly 100 kilometers deep. K2-18b's ocean would exist beneath hydrogen hundreds of kilometers thick. And at the boundary where ocean meets atmosphere, temperatures and pressures would exceed water's critical point. The physical distinction between liquid and gas would cease to exist. Imagine descending through that hydrogen atmosphere. The gas gets denser as you drop, warmer, heavier. At some depth, you realize you are no longer falling through air, you are moving through fluid. Three reasons have converged on one planet, 124 light-years away: chemistry that matches an ocean, a profile that defines a new class of habitable world, and methane at 10,000 times the level any dead planet can explain. The ultimate answer requires more JWST observations over the next 1 to 2 years. Enough transits to either confirm the ocean, strengthen the biosignature, or rule both out entirely. Madhusudan said it plainly. If K2-18b's ocean and biosphere are confirmed, it should basically confirm that life is very common in the galaxy. The logic is simple. Finding life on the very first promising ocean world we closely study would mean oceans and biology are not rare accidents. They are common outcomes scattered across billions of planets. The light leaving K2-18b right now will reach Earth in 2014-90. By then, we might already know the answer, not because we visited, because one telescope, pointed at one quiet planet, read the chemical secrets hidden inside starlight that had been traveling since before anyone alive today was born. We have never been this close before. Subscribe if this planet made you rethink what an ocean looks like. And tell me in the comments, if we find life on the very first ocean world we study, what does that say about every planet we have not looked at yet?